Electricity is a powerful force that plays a vital role in our lives. It can also be dangerous if not handled properly. Electrical hazards can cause serious injuries and even death. It's crucial to prioritize electrical safety in all aspects of our lives, from homes to workplaces. Statistics show that electrical incidents are a significant cause of workplace accidents. According to the Electrical Safety Foundation International, there were 130 electrical fatalities in workplaces in a recent year. These incidents often result from unsafe work practices, lack of training, or inadequate safety measures. One real-world example of the dangers of electrical hazards is the case of an experienced electrician who was working on a live circuit. He was not wearing proper insulating gloves and received a fatal electric shock. This tragic incident highlights the importance of following safety procedures and using appropriate PPE. By understanding the risks associated with electricity and following essential safety guidelines, we can significantly reduce the likelihood of electrical accidents and create a safer environment for everyone. Personal protective equipment, or PPE, is essential for anyone working with or around electricity. It acts as a barrier between you and potential hazards, reducing the risk of injury. When it comes to electrical work, wearing the right PPE is not optional, it's mandatory. Gloves are crucial for protecting your hands from electric shock. Insulating gloves made of rubber or other non-conductive materials should be worn whenever there is a risk of contact with live electrical components. Safety footwear with non-conductive soles is essential for protecting against electric shock. These shoes prevent the flow of electricity through your body if you accidentally come into contact with a live wire or energized surface. Eye protection is vital to shield your eyes from sparks, debris, and arc flashes. Safety glasses with side shields or a face shield should be worn at all times when performing electrical work. Arc-rated clothing provides protection from the intense heat and light generated during an arc flash event. This specialized clothing is designed to self-extinguish and reduce the severity of burns. Helmets protect your head from falling objects and impact hazards, which are common in many work environments. When working with electricity, a non-conductive helmet should be worn to provide an extra layer of protection. Lockout tagout, or LOTO, is a safety procedure used to de-energize electrical equipment before working on it. Its purpose is to prevent the accidental release of hazardous energy, such as electricity, during maintenance or repair work. The first step in the LOTO procedure is to identify all energy sources connected to the equipment. This includes electrical, mechanical, hydraulic, and pneumatic sources. Once identified, each energy source should be isolated and locked out. The next step is to apply a lockout device to each energy isolating device. A lockout device is a physical lock that prevents the equipment from being accidentally turned on. Tags are then attached to the lockout devices to provide a visual warning that the equipment is being worked on. Before starting work, it's crucial to verify that the equipment is de-energized. This is done using a voltage tester or other appropriate testing device. Only after confirming that the equipment is safe to work on should maintenance or repair activities commence. Finally, when the work is completed, the equipment must be properly inspected to ensure it is safe to return to service. The lockout devices and tags are then removed and the equipment is re-energized. One of the most important safety rules in electrical work is to always test for voltage before touching any electrical component. This simple step can prevent serious and potentially fatal electric shocks. Voltage testers are essential tools for determining the presence or absence of voltage in electrical circuits. There are two main types of voltage testers: multimeters and non-contact testers. Multimeters are versatile tools that can measure voltage, current, resistance, and other electrical properties. To test for voltage, the multimeter is set to the appropriate voltage range, and the probes are connected to the circuit being tested. Non-contact testers, also known as voltage detectors, are used to detect the presence of voltage without making direct contact with the electrical conductor. These testers work by sensing the electromagnetic field produced by live electrical current. When using a voltage tester, it's important to follow the manufacturer's instructions carefully. Always wear appropriate PPE, such as insulating gloves and eye protection when performing voltage testing. Section 5. Grounding and earthing, the path of least resistance. Grounding and earthing are essential safety measures that provide a low-resistance path for electrical current to flow to the ground in the event of a fault. This helps to prevent electric shock and protect equipment from damage. In electrical systems, grounding refers to connecting a current-carrying conductor to the earth. This is typically done by connecting the grounding conductor to a grounding electrode, such as a metal rod driven into the ground. Earthing, on the other hand, refers to connecting non-current carrying metallic parts of equipment or installations to the earth. This helps to prevent the buildup of static electricity and provides a safe path for fault current to flow. When a fault occurs in a grounded system, the fault current flows through the grounding conductor to the ground. This causes a large current to flow, which trips a circuit breaker or blows a fuse, interrupting the flow of electricity and preventing damage or injury. Grounding and earthing are essential safety measures that should be incorporated into all electrical installations. They provide a critical layer of protection against electric shock and equipment damage. Section 6. Safe working practices, everyday habits for electrical safety. In addition to following specific safety procedures such as LOTO and voltage testing, it's essential to develop safe working practices when working with or around electricity. These habits can help to prevent accidents and create a safer work environment. One important safety practice is to keep work areas dry and free of clutter. Water and moisture can conduct electricity, increasing the risk of electric shock. Clutter can create trip hazards and make it difficult to escape in an emergency. Always use insulated tools and equipment when working with electricity. Insulated tools have non-conductive handles that prevent the flow of electricity through your body. Never use damaged or defective tools or equipment. The one-hand rule is a simple but effective safety practice that can help to prevent electric shock. When working on live electrical equipment, keep one hand in your pocket or behind your back. This reduces the risk of completing a circuit with your body if you accidentally touch a live conductor. By incorporating these safe working practices into your daily routine, you can significantly reduce the risk of electrical accidents and create a safer work environment for yourself and those around you. Section 7. Emergency response. Be prepared for the unexpected. Despite our best efforts to prevent accidents, emergencies can still happen. Being prepared for an electrical emergency can mean the difference between life and death. In the event of an electrical fire, it's crucial to use the correct type of fire extinguisher. Electrical fires are classified as Class C fires, and they require a fire extinguisher that uses a non-conductive extinguishing agent, such as carbon dioxide or dry chemical powder. Cardiopulmonary resuscitation, or CPR, is a life-saving technique that can be used to revive someone who has gone into cardiac arrest. Knowing CPR and how to use an automated external defibrillator, or AED, can be crucial in an electrical emergency. After any electrical incident, it's essential to report it to the appropriate personnel. This allows for an investigation to take place and helps to prevent similar incidents from occurring in the future. By having an emergency response plan in place and providing employees with the necessary training, you can ensure that everyone is prepared to respond effectively in an electrical emergency. Section 8. The importance of ongoing training and education. Electrical safety is not a one-time event, but an ongoing process. Ongoing training and education are crucial for ensuring that everyone who works with or around electricity has the knowledge and skills to do so safely. Training programs should cover topics such as electrical hazards, safety procedures, PPE, LOTO, and emergency response. Training should be provided to all employees who work with electricity, regardless of their experience level. Regular safety meetings and toolbox talks are also important for reinforcing safety messages and addressing any concerns or questions that employees may have. These meetings provide an opportunity to review safety procedures, discuss recent incidents, and share best practices. Employers should also stay informed about the latest safety regulations and standards and ensure that their work practices are in compliance. This includes providing employees with the necessary training and equipment to work safely. Section 9. Conclusion: making electrical safety a priority. Electrical safety is not just a set of rules but a mindset that must be embraced by everyone. By understanding the risks, following safety procedures, and developing safe working practices, we can create a safer environment for ourselves and those around us. Remember, electricity is a powerful force that should never be underestimated. By making electrical safety a priority, we can prevent accidents, save lives, and ensure a safer future for all.